Today our lesson objective is to look at the surface area rules. So we used our 3 different 3D solids to break up and break apart and figure out how many faces they had. So we'll start off with our cube, keeping in mind that if we unfold it, we have 6 faces there. So our net of our cube looks a bit like this. If I had to do a rough sketch, we've got our 6 faces there. And knowing that a cube is a 3D version of, say, a square, all of these sides are exactly the same length. Okay, so if we have to do, so this is our 2D net, and we're going to have our surface area rules on this side. Then if we need to figure out exactly how much cardboard it takes to make this shape, we need to do 6 times one of these faces. So rule for surface area of a cube is 6 times the face, or the area of the face, which is 6 times side squared. So that's our important rule there. If we now move and we look at there we go, our rectangular prism, so a little box here. This is a pretty common shape that we see, and if we unfold it, it is very, very similar to a cube. It's got those 6 faces again. Alright, but this time, rectangular prism, this time we've got some different shapes. So you can see very clearly that 2 and 4 are exactly the same size, 3 and 1 are the same size, and 6 and 5 here are the same size. So top and bottom of the box, the front and back of the box, and the sides of the box there. So if we had to draw our 2D net, we would have to see very clear differences between, say, the 1 and the 3 and all of that. And remembering that this is actually all the same length. These ones on the sides must match up because they actually do join. And then we've got, whoops, our other sides here. Okay, so what we've got here is a bit more tricky because our surface area has to have 2 of these, so this one and this one. We have to have 2 of these and then 2 of these, right? So our surface area is 2 times the first area plus 2 times second area plus 2 times the third area. Now that looks pretty tricky. Keep in mind though that this area here is always length times width. Now this is about as easy as we can make it look, because every single time we do these rectangles, they're going to be different sizes, alright? Because remember, we had all those different shapes. I don't mind if you draw them out so you can see exactly which ones you're doing. Right, we're going to look at those ones in the next video to how we do an actual example. And our final one that we looked at was a cylinder. So our baked bean tin here. We've gone from a 3D shape, remembering that we unrolled this label and what we saw was the 2 circles on the top and bottom, and then we had this quite large rectangle. So our 2D net looks like this. So what we're really trying to do is find the area of 2 circles and a rectangle. So the area of, surface area of the cylinder is going to equal, we're going to need 2 circle areas, so we're going to need 2 times pi r squared to start off with, and then we're going to have to add in a rectangle because of this. So we know that this is length times width, but the tricky part here is that our rectangle kind of floats along these circles, so it makes our rule a bit trickier. So 2 pi r squared is nice and easy because we've got 2 of these circles. But this time we have to think about, alright, what are the dimensions of my rectangle? Now this side here is actually, when you put it on the can, the height of the can. Alright, can we see that this runs from bottom to top? So we have to do, instead of length, instead of width, sorry, we're going to do height. And the trickier part even now is that if here is our label and here is our rectangle, when it goes on the side and it rolls around the can, we can see that this length, this long length down this way, all the way here, circles around the can. So like this stuff all wraps around the circle here. And we know that the circumference of a circle is pi d. So suddenly our length becomes pi d. So it's actually quite tricky because we've got two circles and then this is relating to the long side and this height is relating to how high the can is. Quite a tricky one, so take a few practice runs and do a lot of examples.